Hello and welcome to another Plodware video. In this video we're going to be looking at a little application that I wrote that helps identify how similar two images are. In this particular example on the screen at the moment we've got pictures of Emma the dog. They're taken 3 seconds apart, they're different file sizes, and they have a similarity score of 1. A score of 0 would be identical. They're not identical. You can see the paw prints here. You can see 4 little indentations, here only 2. There's a shell here which is nearer to the right than it is here, and it's a bit lower down here. And Emma, her tongue is hardly sticking out here. It's sticking out a bit more there. We don't identify these red areas. We just take a general view of the picture and, based on what's called a perceptual hash, give two images an identity or a value of between 0 and 64. 0 is identical, 64 is nothing whatsoever in common. Here's another little example. It was originally one file where someone took a copy and then wrote Spotty on it. This is our other dog at the moment. The images really are identical. It's the same image file, just copied across and written upon. The algorithm, this p-hash, is clever enough to say, well, they're not quite the same, and they have a difference of 3. And a difference of 3, I would say, is highly likely that they are the same image. In this case, we can see they are. Let's give Emma another go. We've seen this picture here before. Here is another picture taken a few seconds later where Emma has moved her head around. The basic scene is the same. There's the shell in the bottom right-hand corner. The framing is almost the same. Almost. Again, we can see almost the 4 little indents there. We can see them fairly clearly here. It's a very similar frame, but the head is turned, the picture's different. This would get a score of 8. The actual distance or difference between two images, calculated via this p-hash concept, gives us what we call a Hamming distance, which the smaller the Hamming distance is, the more alike they are. And that's what we'll be able to do with this software. As always, there's a disclaimer. If you do take the software, it's purely available as is. You can take it, redistribute it, do what you like with it, but do not imply that there's any more legal liability than stated here. And that is, I accept no legal liability resulting from the use of any of the Brightech or Plodware applications. They are provided as is. There is also a second disclaimer. The software runs on the Microsoft Windows platform, and built into the software is a SQLite database engine. I have no connection with either Microsoft or SQLite, except that I am a user of their products. I have no connection with them, the companies named here, their employees, representatives, or subsidiaries. This information, this video is for informational use only or educational, and it's not sponsored nor solicited by a third party. If you decide that you want to download the software, you can find it at my website at ripetech.com. There's a downloads and scripts page, and there you will find a link to the Visually Alike. It's a zip file. It's only got one file in it, the executable. Download it, unpack it, double click on it, and this should appear. If you don't see this but a blue screen, don't panic. Simply double right click on the executable's entry in the file system to get the properties window. Go into the properties, select the general register. There should be an unblocked option. Tick it, make it unblock, apply, OK, and close. Then next time you double click on the executable, this should appear. I've already started the executable. Here it is. and I'm going to be loading into it this folder with 42 pictures. It might be a bit difficult to see, so I'm going to use some tricks to make the font a little bit bigger and also a bit darker. I think that should be enough. Then we'll restart the executable. This is the old one. We can move it out the way. We don't need it anymore. Here comes the new one with the new size. Right. Should be a bit easier to read. The first thing we do is let's drag and drop these files or folders onto this green bar and read them into the program. It works at about 400 images on average per minute. That's an on average, depends on how large the files are. Let's drag it and drop it. 42, 32, count down. It's going to read the files in, create the p hash values. This is the perceptual hash value for each of the files. It's calculated already that 29 of the files have a similarity to another file, where the difference is 12 or less. 12 is an experience value where I think if a distance of greater than 12 is there, it's highly likely the files aren't particularly similar. If it's 12 or less, it's worth looking at because it could be a duplicate of some sort. We've now got all of the files listed here. We can go up and down through the list. If we wanted to change how close the files have to be, we can up and down the distance between them. But for now, for each file that we've read in, there will be a line. Just pick one of general, and over at this end there will be the p hash value. This is the row number, and this says it has a neighbor at row 5, and they are 4 units away from one another. In this case, row 2 has a nearest neighbor of is row 1, and the distance is 0, so they're very alike. And it's possible for us to go in and mark files. There's 4 groups of marking we can provide. When we read in a file, we automatically test to see if it's identical, i.e. a distance of 0. And if so, we work out where we can which of the 2 or more identical files is probably the biggest, and the smaller ones are marked with a 4. A 4 means simply it's alike. It's actually a duplicate or an equals. It's much easier if we simply double right click on any of the files here. We'll start with row 0 or row 1. Double right click. Then up pops this window, and I'll make it a bit bigger. It's the spotty picture, and it says that row 1 has a pixel size of 1500 by 1200. How big the file is, 254 kilobits. How many dots per inch, and the file name. And then it says, okay, we found this one, and we found this one, which is a distance of 0 away. It's row number 2, has a distance of 0, and this one is slightly bigger than that one. So this one is marked as equals. And here is our famous little spotty with the spotty written on it, distance of 3 from this one. If you want, you can go in and say, I'd rather get rid of this one. So what you do is you right click on it, and you get the option to mark it as either with a remove mark, a keep mark, or an equals mark. I'll just show you quickly. I'll toggle the equals mark and we get that. Or I could say no, I'd rather have the remove mark on it, and that would be a remove. Or no, let's keep it. Whatever happens, mark that one as to be kept. So you can go through the files. Just let's pick another one. Row 1, let's row 6. I think row 6 was interesting. Row 6, there it is. Double right click. They look virtually identical, and yet they're 11 apart, which is a significant difference. Why are they a different size? This one's much bigger, but this one has got more pixels horizontally. If you want to get more information about a file, do a right click and just left click, I'll show you why. If you left click, the program tries to get the EXIF information out of the file, and there I can see that this particular picture, row 6, was taken with the Samsung camera. This one was taken with my Sony. So they are virtually identical visually to me, but there is a big difference in the sky. So these are marked as being similar, but only to a level of 11, which isn't fantastic. But in this particular case, it's deceiving because the images are quite different in terms of cropping. Right, what else can we look at? How about, what have we got? Number 9, double right click. 3 cows. All different pictures, taken very close to in time, but you can see here this, if this is our reference, this one is a distance of 9 away because the cows facing differently, and this one is a difference of 10 away. The head is different, the lighting is different. So whether these are to be considered as identical or not is pretty much up to you. But what you can do is go ahead and mark files. Say you decide, let's get rid of that one, let's remove it. Let's remove that one. You can go into the system and say, please only display things which have been removed, or only things which are marked as equal. What's number 21? Why is that marked as equal? Let's have a look. It's the Emma one again, and 21 is marked as equal. This one is marked as equal, but we can tell looking at it, it's these two, that it's equal to that one. So you can build up your markings, and then when you decide, well, okay, let's move these 2 pictures of the cow into another folder. So you click on Actions. We're going to copy. No, let's move. Let's move. Now we get this menu. We want to move the removes. We need to give it a destination, so we click on here and we can get a destination on the desktop called, I've created it already, it's this thing here, destination. And then I can say go ahead and execute the action. There's the 2 cow pictures. We can go back to our source. Where have I put my source? Waiting. Just a minute. Go here. Go into the source. set is. And we did have 42 pictures. Now we only got 40. So that's it. That's the sort of thing you can do with this program. You can identify alike pictures, you can mark pictures, and then you can do move, copy, and delete of those picture groups as you wish. So from Emma and Spotty and me, that's all. Thank you. My thanks for your time. Until the next video. Cheers.